We're going to start on section 1.4, which is on equations of lines and modeling. So this form of an equation of a line that we've been working with in the last section, it gets a name here. It's called slope-intercept form. So in particular, if you have the equation of a line written in the form y equals mx plus b, where m is the slope and b is the y-coordinate of the y-intercept, this is called slope-intercept form. So far and away, this form is the most common one that we'll use, and there's a reason for that. It's unique. There's only one right answer. So essentially, in the end, it makes my job a lot easier. Let's take a look at an example. So in this example, we want to find the equation of the line in slope-intercept form with, in part 1, slope minus 1/3, which contains the point 0.25, and in part 2, slope 2/9, which contains the point 0.37. Let's go over to the whiteboard app and we'll see the solution worked out. In part 1 of this example, we're asked to find an equation of a line in slope-intercept form where the slope is minus 1/3 and this particular line contains the point 0.25. So first of all, what I want to do is start out with the slope-intercept form of the equation, y equals mx plus b. But in this case, I'm going to fill in any m equals 1/3. So what we end up with is y equals minus 1/3 x plus b. And you'll notice here that we don't know what the y-coordinate of the y-intercept is. Now there are several ways to find b here. In my humble opinion, the easiest way to do this is to use this point, 2, 5. 2 is the x-coordinate, 5 is the y-coordinate. So what we're going to do is take that point 2, 5, we're going to plug 5 in for y and 2 in for x. This will leave exactly one unknown, that is b. We're going to solve for that and then put it back in. So let's go along that path. So first of all, I'm going to plug 5 in for y and 2 in for x, and that's going to give us 5 equals minus 1/3 times 2, which as usual I'm going to plug in parentheses, plus this unknown quantity b. So what we end up with is 5 equals minus 2/3 plus b. We're going to solve for b by adding 2/3 to both sides of the equation, and what we're going to end up with is 5 plus 2/3 equals b. So we have to add the fractions on the left-hand side here. 5 is 15/3. So we get 15/3 plus 2/3 equals b. And in the end, what we end up with is b equals 17/3. Now, you'll notice that I don't write this as a decimal expansion. I do not write this as a mixed number. I leave it in improper fractions. And this is something that you want to get used to as quick as you possibly can. So what we're going to use as a convention for pretty much the rest of the semester and the rest of your mathematical career for that matter. So now that we have our b, we're going to take that and we're going to plug it back into this equation here. So that 17/3 is going to, we're going to plug that back into this equation here. So that b is going to become 17/3. So I'll go back to y equals minus 1/3 x plus 17/3. That is the equation of the line that I'm after in slope-intercept form. Go ahead and pause the video at this point and try to work your way through part 2 of this example, which is to find an equation of a line in slope-intercept form of the line with slope 2/9 containing the point 3/7. When you're done, come on back and you can see my solution. Once again, we're going to start off with the equation y equals mx plus b. We substituted in 2/9 for m in this case. Once again, we don't know what b is. So at this point, we're going to take the point 3/7 and we're going to plug in 3 for x and 7 for y. So we go back to this equation, 7 goes in for y. This equals 2/9 times 3, where we've plugged 3 in for x, and we're adding b to that. Now at this point, once again, we have here a fraction. 2 divided by 9 times 3 is 2/3. We're going to subtract that from both sides of the equation here, so we'll end up with 7 minus 2/3 equals b. 7 is 21/3 minus 2/3 is 19/3. And this is the y-coordinate of our y-intercept. So we go back and we take this value that we just found for b, and we're going to plug it back into this equation here. What we end up with in the end is y equals 2 over 9x plus 19 over 3. That's the equation of the line that we're after in slope-intercept form. Now we're going to talk about point-slope form. So this is a different form of an equation of a line, and it's derived from the slope formula that we had from before. So recall that the slope formula is m equals y2 minus y1 over x2 minus x1. So what I've done here is rewritten that formula but lacking the subscripts on the second point. So m equals y minus y1 over x minus x1. So now what we're going to do is move the bottom up over to the other side, and what we end up with is y minus y1 equals m times quantity x minus x1, where I've switched the sides of the equality here. This particular form of this equation is called the point-slope form of the equation of a line. And the truth is you don't see it very often. It's not unique. Your point-slope form of an equation of a line and mine may differ even though the lines that we get are exactly the same. And this is a problem for the guy that's grading your exams because it makes it very difficult to tell whether or not you get the right answer. So for that reason, point-slope form is infrequently used, but it can be used sometimes. Let's see an example with this point-slope form. So in this example, we want to find an equation in point-slope form of the line containing the points minus 1, 5, and 2, minus 4. Let's go over to the whiteboard app and we'll see the solution of this done. In this example, we're asked to find an equation of the line through the points negative 1, 5 and 2, negative 4, and we want to write this line in point-slope form. So we need two pieces of information to write down the equation of a line: the slope of that line and some point that lies on that line. We don't have the slope yet, but we can find it using the slope formula, which recall is the slope m equals y2 minus y1 over x2 minus x1. In this particular case, y2 is negative 4, y1 is 5, x2 is 2, and x1 is minus 1. So I've plugged all those into this formula, and what we end up with is minus 9 over 3, which simplifies down to minus 3. So the real benefit of the point-slope form is that once you have the slope, it's super easy to write down an equation of the line. So for instance, if I choose this point here, the equation of my line is going to become y minus y1, which in this case is y minus 5, equals m times x minus x1, which in this case is minus 3 times x minus negative 1. Now we can rearrange this just a little bit on the right-hand side, and what we'll get is y minus 5 equals minus 3, that's the slope, times x plus 1. This is the equation of this line in point-slope form. Now there's a natural question that you may ask here. What if I chose this other point, 2 minus 4? The answer is the equation that you would get is y plus 4 equals negative 3 times x minus 2. Now, if you look at this equation and this equation, they look very different. And therein lies the problem. Point-slope form of an equation of a line is not unique. It turns out that these two equations are the same, and the easiest way to see that is to put them each into slope-intercept form, y equals mx plus b, and you'll see that they're actually the same equation. It's for this reason that everybody prefers the slope-intercept form. Now we're going to talk about parallel and perpendicular lines. Now, anything that we see in this class has two distinct interpretations. One is the geometric side of things, and that's the pictures, so to speak. On the other hand, you have the algebraic interpretation. That's the numbers and the equations. And parallel and perpendicular lines are no different here. Geometrically speaking, two lines are parallel if they don't intersect as long as they're distinct. Now, if they're the same line, obviously they intersect, but we don't count those as parallel. So two distinct lines are parallel if they don't intersect from a geometric perspective. On the other side of that coin is the algebraic interpretation. Two lines are parallel if their slopes match. That's the algebraic interpretation. Their slopes are equal. Now, we're forced, unfortunately, into the uncomfortable position of always separating out the case of vertical lines. We have to do this because vertical lines don't have slope. So completely separately, we have to say vertical lines are parallel. It's unfortunate, but we have to do that because the slope is undefined. The sort of opposite of parallel is perpendicular. Geometrically speaking, lines that intersect at a right angle are perpendicular. On the other hand, the algebraic interpretation is that the slopes of perpendicular lines are negative reciprocals. Reciprocal, recall, you take a fraction, you flip it upside down, stick a negative on it, and what you'll get is the slope of a perpendicular line. Now, once again, we have to separate out the case of vertical lines. Vertical lines are perpendicular to horizontal lines. Otherwise, two non-vertical lines are perpendicular if their slopes are negative reciprocals. Let's see an example with this. In this example, we want to find equations of lines which, as usual, are going to be in slope-intercept form, passing through the point 2, -3, and in part 1, parallel to, and in part 2, perpendicular to the line 4y minus x equals 20. A couple things to note here. I've put in slope-intercept form in parentheses here. That's because oftentimes it won't be stated. Unless otherwise stated, you should always write your equations of lines in slope-intercept form. It's so common that a lot of times we just skip saying it. The other thing that you have to watch out for in this problem is the following. There are two distinct lines running around in this problem. There's the one that you're given, 4y minus x equals 20, and there's the one that you're trying to find, either parallel in part 1 or perpendicular to that given line. As such, you have to keep these things separate in your mind. There's the line that you're given and the line that you're trying to find. Let's see this worked out by going over to the whiteboard app. In part 1 of this example, we're looking to find a line parallel to 4y minus x equals 20 that passes through the point 2 minus 3. Just like always, when we're finding the equation of a line, we need two pieces of information, the slope and a point that lies on that line. In order to find the slope of the line that we're looking for, we first need to know the slope of the line that we're given, 4y minus x equals 20. And to do that, we need to solve for y in terms of x. So a first step along that path is to add x to both sides. This gives us the equation 4y equals x plus 20. We then divide both sides by 4 to give us the equation y equals 1/4 x plus 5. Now, the piece of information that we want here is the slope, 1/4, because we know that the slope of the line that we're looking for is the same as this given line. That is, the slope m of the line that we're after is also 1/4. Now, at this point, I'm going to throw the rest of the information from this equation away. In particular, the y-intercept of the equation that we're looking for is unlikely to be 5. In general, that's not going to be the case, and in this particular example, it's definitely not going to be the case. In order to find the equation of the line, we go back to the slope-intercept form of the equation of our line. In this case, y equals 1/4 x plus some unknown y-intercept b here. In order to find b, as usual, we're going to take the point that we're given, 2 minus 3, plug it back into this equation, and that's going to allow us to solve for b. When we plug in x equals 2 and y equals minus 3, we get the equation minus 3 equals 1/4 times 2 plus b. We then subtract 1/2 from both sides to get b equals minus 7/2. We then take that y-intercept, we plug it back into this equation here to get the final answer of y equals 1/4 x minus 7/2. This is the equation of the line that we're after in slope-intercept form. And notice in particular that our y-intercept is different from the y-intercept of the line that we were given. So at this point, we're going to work on the second half of this problem, which is to find the equation of the line in slope-intercept form, which is perpendicular to 4y minus x equals 20, also passing through the point 2, -3. Go ahead and pause the video at this point, try the solution for yourself, and then come back when you're done and I'll show you mine. Now, the nice thing about already having done part 1 of this problem is we can take a bit of a shortcut. We know from part 1 that the slope of this given line is 1/4. As a result, the slope of the perpendicular line, that is the line that we're after, is the negative reciprocal. That is, the slope of the line that we want is m equals -4. Once again, we go back to our y equals mx plus b, that is the slope-intercept form of the equation of the line. In this case, y equals -4x plus b. And once again, we're going to use this point, 2 for x, -3 for y, to plug into this equation to solve for b. Once you do that, you should find that the y coordinate of the y-intercept is b equals 5 in this case. So we take that y-intercept, we plug it back into this equation, and what we end up with for the final answer is y equals -4x plus 5. That concludes section 1.4 on equations of lines and modeling. See you back here for section 1.5.